Hey folks, this is Tozzi with IT Pro Today, and I'm here to talk to you about open source tools that developers can use. And you might be thinking, how can one guy in one video possibly talk about all of the open source tools that a developer today might want to know? And that's a fair question because there are, of course, literally thousands of open source tools that modern developers might use. And I'm not going to talk about all of them today, but I do want to talk about 4 tools that I think almost every developer today should use for open source tools specifically. There are going to be exceptions, but I'll try to make the case that these are all tools that if you build any kind of software today, you probably want to know about. The first of those is Linux itself. And admittedly, Linux isn't really a tool. Linux is a platform that includes hundreds of individual tools. So I guess I'm stretching the definition of the word tool here a little bit, but setting that aside, I would make the case that every developer today should know Linux. And of course, if you know much about Linux, you know that the screen you're looking at right now is a Linux desktop screen. And I think it's important for every developer today to know Linux, not because all developers build applications for Linux. That's not the case, right? There are plenty of developers who never, who write code that will never touch a Linux-based operating system. But the reason it's important to know Linux today is that a lot of the tools developers know are made to look and feel like native Linux tools, much more than they are tools that you'd encounter in the Windows world. So, for example, even if you're a Windows developer, you might have to spin up virtual machines in the Azure cloud, and you might do that using Azure's command line tools, which, even though you can run them from Windows, they really look like Linux command line tools. So that's one example out of many of why it's valuable to understand how Linux works, basically understand how to think like a Linux user. I would put it in those terms, I guess. I think that's important for almost every developer today. Even if you don't actually use Linux, you should know what Linux is, how it works, how it's different from Windows. And one way to do that is to actually download and install Linux. You can run a distribution like Ubuntu, which is what I have running here, although I have this interface is different than the one that Ubuntu currently provides by default. Or you can use Windows Subsystem for Linux, which is basically a framework that lets you run Linux tools natively right on a Windows machine. So even if you use Windows today and you don't actually want to deal with having to install Linux, which by the way is much easier than you might think it is, but even if you don't want to have to go to that trouble, you can still use Linux really easily today right from Windows using Windows Subsystem for Linux. So go and do that. If you don't know much about Linux, go and experiment. So that's one tool/platform that I think modern developers need to know. Another is Git. So let's talk about Git a little bit. So Git itself, right, is a command line tool that runs on Linux or Windows, although it was originally developed for use on Linux, and it's designed to help you manage source code, right? So you can run Git directly from a command line. Git's only native interface, by the way, is a command line interface. Git natively does not provide any graphical interface. However, if you use Git as a developer today, you may or may not actually have to familiarize yourself with the command line interface, which is what you see displayed here in the terminal, because a lot of developers today use Git via platforms like GitHub or GitLab, which essentially are web-based interfaces to Git, right? So if you use GitHub to manage your code, you're using Git's features, except you're accessing them through a website rather than having to type commands on a command line. Although if you wanted to, you can use Git to interact with repositories that are hosted on GitHub. I mean, that's a thing. But in general, not all developers today necessarily use Git itself, but all of them, or virtually all of them, are going to use some kind of Git-based version control and source code management system. And for that reason, even if you do manage your code through GitHub or GitLab, I do think it's valuable to at least download Git, the command line tool, get a sense of how it works. I mean, just the default output here gives you a sense of all of the things you can do with Git that might be interesting to you if you are a developer and you need to manage code. So again, even if you never actually run Git yourself directly, learn what Git is, and then you go ahead and use a platform like GitHub or GitLab if you think that those are easier ways to use Git. And I guess it's worth noting too that those platforms provide additional features that aren't part of Git itself. So that kind of stuff is cool. Like on GitHub, you get GitHub Actions. You can scan code for security reasons, for example. You can do a bunch of other things that you can't do with Git, the native open source tool. But still, in a way, that's all the more reason to learn Git itself, because I think it's important to understand what Git can do natively and what you have to turn to third-party platforms to do by taking advantage of features that are built into those platforms, but that aren't actually part of Git itself. So that's Git. Let's talk now about another command line tool that I think most developers should know today, and that tool is Docker. Now, if I were making this video 5 years ago, I would say that almost every developer on the planet should familiarize himself or herself with Docker. And when I say Docker, by the way, I mean Docker, the open source platform, and the tools that are built into it for creating and running and managing containers. Now today, I don't think everybody needs to know Docker, because in many cases, let's type Docker, by the way, and see the default output. Oh, I guess, well, there we go. I thought it was going to hang for a moment, but you can see here you can do lots of cool things with Docker and its command line interface. But as I was saying, a lot of people today don't actually use Docker anymore, because today, if you run containers in production, chances are you're deploying them using Kubernetes, the open source orchestration tool, which we'll talk about in a moment. And under the hood, Kubernetes sometimes uses Docker as its runtime, although you can use other runtimes with Docker, or excuse me, with Kubernetes. But my point here is that if you're using, if you run containers today, you may or may not actually use Docker to run them. And you also don't necessarily need to know the Docker command line tools anymore, because in most cases today, you would manage your containers using Kubernetes and its native tooling. Even if you use Docker as the underlying runtime in Kubernetes, you don't necessarily need to know how to manage containers using Docker's own tools. And Docker itself, to be clear, is separate from Kubernetes. They're separate projects, totally separate sets of tools. They both kind of do related things, but distinct things. So again, the point is, if you use Kubernetes, you don't need to know anything about Docker in particular necessarily. That said, the reason why I think most developers today should still learn Docker is that, well, really there are two reasons. One is that if you do build applications in containers, being able to run them using Docker's native tooling on a development machine is really useful for testing purposes, right? If you just want to run a one-off application instance inside a container, you can do that by creating an image locally with Docker and running it right on your machine. That's a lot simpler than having to set up a Kubernetes cluster and deploy your application that way, which you could do. You could do that locally too if you wanted, but it's more work, right? If you just want to run a containerized application quickly so you can test it, Docker is the way to go. The second reason why Docker is useful for modern developers is that it's also just a fast and easy way to run software that you might need to deploy on your development machine, right? So for example, let's say I want to run a MySQL database. I'm going to log in as root here because I am lazy and I did not configure this machine to have the right user permissions for Docker to run as my normal user. So don't do this. This is insecure, but I'm going to do it because, again, I'm lazy at the moment. But if I wanted to run a MySQL instance here, I could just do Docker run MySQL, and it would go ahead and it would download a MySQL container for me, and then it will actually run it, right? I'm not going to wait for it all to download, but that's pretty cool, right? Docker, in that sense, gives you a way to run applications quickly and easily, and also it's a method that's consistent across any machine. No matter which Linux distribution I was using, I could run MySQL this way. The downside is that I would have to, if I actually wanted to use this MySQL database, I'd probably have to do some configuration to make it interface with whichever applications I wanted to connect to it. But still, it would still probably be easier overall than having to install MySQL another way and then configure it locally on the machine. And then when I was done using it, I would be left with a bunch of sort of cruft, for lack of a better word, right? Whereas with Docker, once I'm done running MySQL or whatever else I want to run, I just shut down the container and it's gone. It doesn't really leave any traces behind on my system other than the container image itself, which I could quickly delete if I wanted to. So anyway, Docker, still a tool worth using if you're a modern developer. Maybe not quite as important as it was 5 years ago, certainly not 10 years ago, which is when Docker came out. But it's still pretty useful today. Finally, related to Docker is Kubernetes. As I said a few moments ago, today the way most people run containerized applications in production is in Kubernetes. And that means that if you're a developer building software that will be deployed inside containers today, you should probably know something about Kubernetes. Now, I'm not saying you need to be a Kubernetes expert. That's probably only necessary if you're actually administering Kubernetes. But if you're a developer building applications that will run in Kubernetes, I think you do need to understand the basics of how Kubernetes works, understand what the architecture is. That stuff is important if you want to know how to write an application that will be optimized for performance in Kubernetes and also be secure, right? Kubernetes works in fundamentally different ways than basically any other platform out there. So a basic understanding of how it works is important. And, if you're thinking Kubernetes is really hard to set up, I don't want to do that, I would argue that you're wrong because it's true that running a production Kubernetes cluster is pretty complicated. But one of the cool things about Kubernetes is there are a bunch of lightweight Kubernetes distributions out there that you can spin up on a local machine and get a cluster up and running pretty easily. One of them is Rancher's distribution called K3S or K3s, if you want to call it that. This will run on a local machine. Canonical has a distribution called MicroK8s, which also runs locally pretty easily. I actually like MicroK8s a lot if you're already using Ubuntu because it's really well integrated with Ubuntu, but the downside is it's harder to set up on non-Ubuntu systems. So my kind of go-to lightweight Kubernetes distribution is this one called Minikube, which is from the Kubernetes project itself. So it's a quote-unquote official lightweight Kubernetes distribution, and it's easy to set up. As you see here, they give you the commands you need to run this on any operating system, and with just a couple of commands, you can go ahead and install Minikube on your system, and then you can start it with a single command. This will set up a cluster for you, and once your cluster is running, you can go ahead and start deploying containers in it. And you can also experiment with the cluster configuration. You can experiment with different networking and storage settings. You can experiment with, setting up multi-node clusters, high availability clusters where you have multiple control plane nodes. That's all stuff you can play around with right on a local machine to sort of walk yourself through how Kubernetes works. And again, I think that understanding Kubernetes is a pretty essential skill. Kubernetes is, again, maybe it's a stretch to call Kubernetes a tool. Maybe like Linux, it's more of a platform. But it's open source, and it's an important tool / platform to know for most developers today. And so that's it. Those are my 4 essential tools. If you said to me, you have to pick 4 open source tools that every developer should learn today, what are they? These would be my top 4 choices. Linux, Git, Docker, and Kubernetes. Arguably, there are plenty of other open source tools that are at least as important as these, but that's debatable, right? It's subjective. So thanks for listening. Hope you learned something, and stay tuned for future coverage of the open source space and lots else from IT Pro Today.